Okay, so someone on my Discord sent me a list of questions he was asked in an actual interview he was doing for a junior position for a React front-end role, I believe. But anyway, let's just kind of go through these, and I think just understanding how to answer some of these things will just overall make you a better developer in terms of JavaScript and how some of this stuff works under the hood. So types of variables in JavaScript. This one should be pretty easy, right? You have const, let, and you have var. And knowing how to explain the difference between them, well, so a const basically means you cannot reassign it, right? So once you assign a const, you cannot come down here and you can't reassign it again. Pretty straightforward. You should kind of know that. Let means it's something that you can assign differently. So for example, I can go ahead and like assign this to something else and it won't complain. Same with var. Var will also allow you to reassign, but the main difference between const, let, and var is that var is not block scoped. So for example, if you have an if statement, I believe, this is going to be a block. If you declare a let inside of here, so I say like let hello equal to hello, this is only going to be accessible inside these curly braces. If you try to console log this down here, I believe it'll say, like, I think your program will actually crash. So let's try this out. I'm going to go to JSBin real quick. Let's just run this and see what happens. Go ahead and click run, and it does crash. Hello is not defined. Okay, so this is the difference between like let const versus var. If I did var here, this would actually, due to like hoisting, this would be pulled up to the very top, and this would actually print out hello, I believe. So let's run this, and it does print out hello, although you cannot see it, and for some reason, let me try clearing the console and just rerunning it. Okay, so this prints out hello. So yeah, that's kind of like the difference between them, and why you might want to use some of them. But I'm assuming you guys kind of already know that. Most of the people watching my videos are not like super beginners. So type of variables should be easy. Difference between let, var, and const, we just talked about that. In most of the time, you're going to be using const. Using let and then assigning something and then reassigning it later on typically just makes your code harder to understand. Versus if you just have a bunch of constants, and if you need to like have an array set to a constant and then you need to like modify that array, then I would just make a new constant called like modified array equals the old array.map, something like that. But anyway, that's kind of the difference between them. What is hoisting and why does it exist? So in JavaScript, hoisting, like I kind of showed here, is basically when you declare variables, it's going to pull that variable up to the very top so that you have like access to it. A good example, if I did like a function, so function hello, if I were to call hello up here and have this thing like console log something, this will run because the way JavaScript works, when it sees like function declarations and variables, it'll kind of like pull them up to the very top of the file so that you don't get some type of like hello is not defined issue. Now a difference is if you were to set this to a const and let that equal to an arrow function, this is actually not going to be hoisted. Like this is going to be declared in the order. So if you try to access hello here and call it, it's not going to work, right? Because the constants are not hoisted. I don't believe lets are hoisted either. So vars kind of are hoisted, but I will say that like you have to understand the difference between the declaring of the variable and actually assigning it. I think the assigning will still happen in the order of your code, but the declaring is what kind of gets pulled up to the top. So for example, if I just did like a var hello here, and that's basically behind the scenes, it's kind of just doing this in JavaScript. So although you're not getting a syntax error, this thing is still not declared yet. It's not assigned yet. So this will actually fail, which is why we see it. But anyway, that's kind of how it works with functions, at least, where you can kind of declare a function, but then call it before you actually declared it, because JavaScript will automatically pull that up to the top. Why is that useful? I think it just kind of reduces the overhead. Sometimes if you have like a bunch of functions and those functions call other functions, like for example, if hello called, let's do this. If hello called A and then A called B, right? If you didn't hoist these things, then this would just throw a bunch of errors because A wasn't defined yet. So you'd have to basically manually go through your code, pull that up to the top, kind of a pain. Oh, but then B is not defined yet. So I have to manually go here, pull that up to the top. So I think that's kind of the benefit as to why JavaScript does hoisting. I think it makes the developer experience a little bit better. But that's all I kind of know. Maybe there's like some other reasons that you guys can leave a comment on of why. All right, so next one, what is object.prototype and proto? For an example with get prototype of or set prototype of. I don't think I've even used these functions in years. Again, I work mainly with React and stuff and like Node in the background. And there's like ES6 classes. So I kind of don't even know why they're asking this. I mean, knowing what the prototype is kind of important. But So a prototype is basically like the object-oriented approach to JavaScript before they added ES6 classes. So if you wanted to make like a person, so I say like function person, this would be like a person constructor, right? So if I wanted to return, if I said like this.name is equal to Bob, and then I go ahead and say const p is equal to new person here, I just go ahead and console log p.name. This will basically use this function to construct a new object. And this is the constructor here. This is kind of how you do stuff with the JavaScript approach to things. But when you do this, this thing actually has the ability to attach things onto what we call a prototype. So if I were to do person.prototype, say hello, and I set that equal to a function, and I just go ahead and in here to just say console log hello. Basically now every single thing that we construct, every instance of this person class that we construct is going to have a method attached to it automatically. And that's because when we do the new keyword, it basically takes the prototype of person and it's going to append all the methods that we kind of like assign to it. So for example, if I were to say p.say hello and run this, it prints out hello down to my console. Okay. For the most part, like it's not too important to know prototype because in this day and age, like we should be using classes, right? If you're doing object-oriented programming, you're going to make a class object like this. I'll say class person, and then I'll say like constructor. And inside the constructor, you can actually like define this.name is equal to Bob. And inside of the class itself, I could give it a method that says say hello, and then I could put the console log here. So all that need for the prototype stuff kind of gets abstracted away when you're using ES6 classes, and it does the exact same thing. Under the hood, it's kind of using prototypes to build up the same object, but basically the prototype is kind of like the blueprint of how your object should look like after you construct it, and all the methods that should be on it, and all the members that should be on it. But I think that's kind of a good overview of that. Now get prototype of, set prototype of, I don't think I've even used these. Like what happens if I do this? Let's just try saying get prototype of, and I'll pass it p. Does this actually do something? I don't know. Let's go ahead and run this and see what happens. Get prototype of object.getPrototype of. So the object.getPrototype of, I guess, is a static method that exists on the object class or object, whatever this is. And if I run it, let's see what happens when you run this thing. It prints out a ... right? So I guess the purpose of this is that you can check if an object extends a particular prototype. So let's just try this. Again, I don't think I've ever used this in my 10 years of coding. I don't think I've ever used this function before. So I don't know why they're asking that in an interview. It's kind of stupid, but hey. If I just put person here, let's see what happens. Is object.getPrototype of p equal to person? Is this going to print out true? Or is this going to print out false? That prints out false. Let's try person.prototype here. And let's see what that prints out. That prints out true. Okay, so again, it's kind of like trying to see if something extends something, but honestly, like, I'm not sure why you even do this, because you can say is p instance of person. Okay, which will also basically check is the instance that you're checking, is it a type of person? So again, this question, I don't know why you'd even ask these things. Like, I don't think people actually use these anymore. Like ES6 classes have been around for years. Why are you quizzing people on object.prototype and like these lower level methods? But hey, I guess whatever, the interviewer thinks it's important, so whatever. What is the difference between a class and an object? That was kind of like a question about object-oriented programming. So again, we just talked about a class, and a class is basically an approach for coupling the data and the methods that modify the data together, right? So this person has methods on it, and those methods typically use the members of the class to kind of do things. Okay, that's kind of what a class is. Now, an object can potentially like achieve the same thing, but an object typically is just like a more like lower level construct, because at the end of the day, like this P that we created, this is an object, right? If you were to do a type of P, this will probably print out object here, right? Right, so it is an object, but the class is more of like a blueprint of what the object needs to look like after you construct the instance of it. Okay, I don't know if I explained that well, but Again, object is just like the lower level construct of you can have some data and just attach properties to it and attach methods to it. A class is more of like an object-oriented approach of defining methods in properties, and if those properties should be private or public and stuff like that. It's more of like a blueprint, in my opinion. That's what a class is. Don't know if I explained that right, but I'm going to move on. What is this keyword, and when do we use it? So I think that this keyword is all about like the execution context. I don't know if that's the proper term for it, but depending on where you're calling this thing, this will point to typically the reference of that thing. So for example, if I say p dot say hello, if this say hello method used, for example, name, like if I were to just go ahead and say, instead of console logging hello, I'll say print.this.name. This keyword is going to reference the thing basically before the dot, right? So say hello, since we're calling this method and this method is attached to p, this is going to use the name that we kind of set up here. Let's just run this and let's verify that I am right. So it should print out Bob, because again, this is referring to the actual, like, the underlying object that the method was invoked on. And so this is going to be actually referencing this. And I think when you're doing the new keyword, it basically sets this to like a new object. And this, we kind of like decorate it with properties and stuff. But yeah, I mean, this keyword, usually when you're doing like object-oriented programming and stuff, you have to use this to kind of reference the properties of the object that you're playing around with. I think half the explanations I give on this video are going to be like very wishy-washy, but again, I think in an interview, it's just like, can you explain it to enough that you feel like you know what you're talking about? Like, I don't think you have to give like a perfect dictionary definition of what these things are, but like, can you actually show that you know how to use this keyword? Do you know how to access things on an object using this? So that leads us to the next question. What is the difference between a normal function and an arrow function? So the kind of talk about the arrow function, it all boils down to this context, right? What is this going to be pointing to? And depending on if you're using the arrow function or if you're using a normal function, this will either point to the normal execution context thing that it should be pointing to. I'm so bad at explaining this. I feel like I can't even explain this properly. But an arrow function is a way to basically pass this value further down into another function. So for example, this is a good example I can think of. Let's say set hello did a timeout of 1 second, and I want it to console log this.name, okay? So when I run this, after 1 second, it will print out this.name, and it'll print out Bob. But the only reason this is working is because we use an arrow function here. When you use an arrow function, behind the scenes, I believe is doing just like a normal bind on the function, and it's passing this reference even further down. That was probably super confusing what I just said there. But when you use the arrow function, you know, a better way to explain this is let's convert this to a normal function. Let's just make this a function instead of an arrow function, and let's see what happens when you try to run this. Will it print out Bob? It does not. It prints out result. I don't know why it's printing out result. There must be something on the global that is set to result. But the idea is that this is no longer referring to this name here, right? This is no longer referring to this because inside of this function, we kind of changed what this will point to. So that's kind of why you want the arrow function. Now before the arrow function, what we actually used to do, I think, is we said like const that is equal to this. And then inside of here, we say that.name. And this would kind of achieve the same results. It's just like a very hacky way to do it. Notice that it prints out Bob now. But due to like the closure, we basically pointed a reference to a that variable to this variable. And then when I console log that.name, it's actually referring to the original this, not the one that would be overwritten because we did like a set timeout with the new callback function. So that's kind of what's happening behind the scenes. I do believe what's really happening is this is probably calling like a bind here, and this is calling a this for us. Let's try this again. This should also, oh, this is saying that is not defined. Let's rename that to let's rename that to this. And again, this works the same way, right? This is the same as doing an arrow function. Basically, it takes the function, it calls a bind on it, which is going to kind of change what this is going to reference. And then when you invoke the function after a second, this is actually going to refer to this thing. Super confusing. I personally would always avoid using the this keyword if you can, but sometimes when you're using object-oriented programming, you can't. But that's kind of what the arrow function is. I don't know if I even explained that good. I kind of jumped all around, but I showed you like what it's kind of doing under the hood. It's kind of like a syntactic sugar, I believe, for like the bind function that you can call on functions to change what this references to. Let me move on before I confuse more people. What is a promise? Okay, so this one's super important. If you're doing any type of coding with JavaScript, you gotta know what a promise is. So a promise is a way to basically run some type of asynchronous code, for example, like making a request to a backend, and being able to register a callback or like run some code when that asynchronous requests finish. So like for an example, I think with JS Fiddle, I'm not sure if I can do fetch requests. Let's try doing this. Let's go to the Pokemon API and let's see if it allows us to do like a fetch request here. I might get some type of random CORS error if I try to do this, but I'll do fetch and let's just try to get ditto. And let's see what happens if you run this. Does this give us a CORS error? Let's just console log this. Okay, so notice when I console log this fetch request, this prints out object of promise. So this thing that comes back is actually a promise. And the idea is that like, it may or may not be resolved yet, but the idea is that it can resolve at some point and you can attach some type of callback functions on it to run code when stuff resolves. So let me show you how that works. Like basically there's two methods you can typically attach to a promise. There's a .then callback where I could just go ahead and pass it like a function like console log, and that should run or print out the results that we get back when this thing is done running. And there's also a .catch method. So like catch, and then I could just say console.error. So if anything happens when I'm trying to make the request and it crashes, it's going to call the catch callback function, if I spelled that right. So when you're dealing with promises, this is basically how you can do stuff with them. There's also a finally thing that you can do. You can do like whatever code you want to do here. But basically, if everything was fine and the request works fine or your promise resolves, then it's going to call whatever callback function you pass here. If this thing has an error or it fails or it throws an exception, it's going to call the callback that you passed here. And then the finally is basically just something you want to run at the very end of either it being successful or failing, such as like some cleanup or something. Okay, so pretty straightforward. So again, this is like super important. You got to know how promises work. And again, I just kind of like touched the surface of promises, but it's probably good to understand how to construct your own promises. If you haven't actually tried to create your own promise using a new promise constructor, you should probably look into that. So for example, if I wanted to make a promise that when I run it, it just returns G inside of this, I can do something like this. I could say const p is equal to this new promise. And then that's going to take a callback that's going to resolve some string. You can also take a reject here. So like I say reject. And if something goes wrong, you can reject it. And that's basically how you control if you want to do a .then or a .catch inside your custom promise, right? You either resolve it, which will call the .then, or you reject it, which calls the .catch. So in our case, if we have this promise here, we can actually just, instead of doing like a Pokemon fetch, let's just do a .p here. So p.then. If I run this, what do you think it's going to print out? It's going to print out G, because this is resolving a G, which means it's going to call the then. If I were to change this to a reject, what do you think this is going to print out? So it prints out bad. Again, I don't know why this thing is printing out like a weird link here. I don't know if JS Fiddle has some like more error catching that's going on. But that's kind of like an overview of how promises work. How do you use promises outside of async await? So that's kind of exactly what I showed you, right? So what I should probably show you instead is like, how does this stuff work with async await? So let's say you had an asynchronous function called main, and you call it down here. When you have an async function, you can actually use some syntactic sugar so that you don't have to do the .then and the .catch everywhere, right? You can actually just do try catches like this. I can do a try catch. And then I could just go ahead and say console.error, ERR. And then inside of here, I could say await, for example, P. So this is basically the exact same code as this. I'm basically saying, wait for this promise to either resolve or reject. And if it throws an error, we're going to catch it here. And you can also tack in a finally here if you want to as well. Like that's something that exists on try catch finally. and you can do whatever code you want to do here. But this is basically the exact same code. And if I run this and change that to a G, it should still print out a G. Actually, it won't, because I need to actually get the result. So like the await allows you to basically take the resolve value and put it in a variable so that you can kind of do what you want with it. So I can just go ahead and say like print out result. Go ahead and run this. And we got an unexpected identifier. I think it's because I forgot to put function here. Let's just go ahead and run this again. And notice that it prints out G. Okay, again, this is the exact same code as it was before, but now we have like the ability to do async await, which can sometimes make your code cleaner. Sometimes it actually makes your code a lot harder to understand, depending on how many like nested try catches you end up needing. So jumping back and forth between async await and just normal promise chaining, kind of important to understand. What does it mean for something to be mutable and immutable? Which types of variables are mutable and which are immutable? With some follow-up questions on mutability in React. So again, mutatable means you can declare a variable or something, you can change it in the future, right? So we kind of talked about that a little bit with const. So if I say like const name is equal to Bob, this is now immutable. You cannot change this variable, right? If I try to change this to something else, this will actually just throw an error because this constant makes this thing immutable. Mutability is using a let. Okay, so now you can actually change this variable, have it point to other things. That's kind of like the general overview of what something is immutable or mutable. Now you can take it a step further, right? You can have like objects. So if I say const object is equal to like name of Bob, this object is not immutable. You can actually say object.name is equal to ABC, and this will work perfectly fine because constant just prevents you from redeclaring or reassigning what object points to. It doesn't prevent you from changing the object here at all, right? So keep that in mind that this object is mutable. You can change it. But one workaround is you can do object.freeze. This is built into JavaScript, and now this thing is actually immutable. And if I try to change a property on this, it's going to throw an exception. Look down here. At least I thought it was supposed to. I'm not sure why that did not throw an error. Try running that one more time. Okay, so I probably have to go and refresh my memory about what object freeze does, but notice that although we are reassigning name to ASDF, this thing is still printing out Bob because we made this object basically immutable. You cannot change it. It's stuck in time. It's frozen. And there's benefits to that. It kind of helps your code be easier to predict what's going on. I think the biggest argument as to why you want to use this is if you've ever coded in JavaScript and you have a function that takes in like an object, and you take that object and you pass it to more functions, and then you pass that object to even more functions, any one of those functions can modify the object, and it becomes very hard to track like what's changing this object. So that's the argument for why you want to try to make code immutable. Now, I do think there's a little bit of dogma around that ideology. I think it's just, you know, with great power comes great responsibility. I think you can write more concise code with using mutations and mutable code, but it comes at a cost, right? You can add some kind of hard to debug issues in your code base, but usually your code's a little bit more concise because you don't have all this extra like weird stuff you have to do. Like if you've messed with React state, you know what I'm talking about. You have to like return an object that's spread over the previous object and like attach a property to it. It's kind of a lot of work. But yeah, I think you guys hopefully get the idea. What is a closure, and give an example? Okay, so a closure, like for example, is just the idea that you have like variables that are going to be scoped inside of the function when you create it. So the easiest way to create a closure is by using like a higher order function. So if I have a function that's called like, I don't know, make. Okay, maybe not make. Actually, I'll call it counter. And inside of this thing, let's just have it return another function that has like a let count equal to 0. And every time you call this function, I'll say count plus plus. Okay. And so what a closure basically gives you is that this function is going to refer to a variable that is scoped to when this function basically ran. So if I were to go ahead and say like, so if I basically say const c is equal to counter, this is going to run this function. And due to how closures work, this count variable is going to be scoped to the execution of this function. Okay, so right now this is a function. If I were to print this out and say like, what is the type of this? Type of C should print out function. But the cool thing about this is that this is a closure. I don't know how to actually say this correctly. It's like, is the count variable closed over this function, or is this function closed over the scope of the counter? Like, there's some stuff that I'm so bad at explaining, but the concept should still be there, that basically this function has access to some type of like private variable, and no one else can know about it, right? This is like special only to this function here. And now when I call this thing, like if I were to call it a couple of times, in fact, I should probably return this. Let me return that. If I call this a couple of times and put it in a console log, you'll see that it prints out 0. And then if I do it again, it'll print out 1. I don't know if you guys can see that. It's kind of like at the bottom of my screen. Let me do this. Right, so every time you call it, this function that we created is just incrementing a variable that's kind of like private. I don't know. I'm going to move on from this topic because I don't think I'm going to explain this too well, but that's kind of like what the closure does. What is a JavaScript closure? This is one of those things where it's like I've been coding with JavaScript for so long and I still can't explain like what exactly it is. All right, let's just give the definition because I think I did a bad job at explaining this. A closure is a combination of a function bundled together enclosed with references to its surrounding state, the lexical environment. In other words, a closure gives you access to an outer function scope from an inner function. So it's basically the fact that I can access variables outside of this function. Okay. And it says in JavaScript, closures are created every time a function is created at function create time. So anytime you create a function here, like for example, when I create this function will have access to this name variable. So I don't know. I probably would have not been able to explain that too well in an interview. It's one of those things where it's like, I know how to use it. I could literally code up some code that uses closures, but when you tell me to explain it to you, it's like, I don't really know how to explain it too well because I just can't, the terminology just doesn't come out of my mouth very well. Let's just move on. Why are block scope rather than function scope variables not available after we exit a function? I read through this one. I have no idea what this is asking personally. I understand what block scope variables are. Like if I were to say I have a function here that's like called main, and inside this function, if I declare like a block and say const x is equal to the string of 1, and I try to console log x down here, right? This is not going to work, right? Because this thing, this is scoped to this block, right? If I run this, I think it should crash. X is not defined. But like I understand what block scoping is. Same thing with an if statement. If I have an if statement here, again, this thing has a block on it. If I try to run this code, this will crash because again, you're trying to access some type of variable that's only scoped to this block. Now the question is, why are block scoped rather than function scope variables not available after we exit the function? Right, and I don't know if this is a question that's like asking more about the call stack and stuff, and I had a discussion on Discord about this question, and I just don't understand it. I don't understand what they're trying to quiz you on. Like if it's just the fact that like you can have block scope variables, then I think I kind of answered that question. Well, if they're asking for more information, like I probably would have not gotten this answer right. Everything about front-end caching and caching in general, what is the difference between local storage and session storage? Redis was also brought up. This is like a separate question. This is also kind of a separate question. I mean, I guess you can consider local storage a cache, I guess. It's more of like a storage area. But so caching is basically a way to increase the performance and load time of your website by using data, potentially stale data, instead of like going off to the server and fetching the new latest, greatest version of the data. So for example, when I load jsfiddle.com, it probably loads in a ton of different things. But on the second load, my browser actually caches a bunch of these things so that I don't have to go back to the server again and refetch all of the unmodified data, right? So all of these files, they probably don't change that often. The CSS, maybe they do a deploy every couple of days and the CSS will change. But if I load this app like 20 times a day, I don't want to have to keep hitting the server over and over and over again to get the exact same file. So that's kind of why we have caches. It's a optimization that clients can use to basically be quicker to run and reduce the load on the server so that you don't have to fetch things that you already know you already have. And this can also be applied to like caching data in your application, right? So sometimes when you have like a widget that loads, you have to fetch data from an API. And if you were to navigate to another page that has to use that same data, well, you just loaded it, right? So you can store that somewhere in your browser memory in like a variable. Or if you're using React, you can store it in like a provider or something, or you can store it in like a state management library like Jotai, Zustan, Redux or something, and basically cache that information somewhere so that when you try to load from the API again, you can check, okay, when was the last time I loaded this data? Has it been like 60 seconds? And if so, I could just, use the data I have locally. If not, I need to go to the API and get some new data. Now, there's a bunch of caching solutions out there, like React Query is one. There's a whole paradigm called like stale while revalidate. I think it's called SWR. This takes care of a lot of the caching that a lot of React applications and just front-end frameworks use in general. Basically, again, fetch data from the API and cache it somewhere so that if I ever need to fetch again from that API endpoint, I can just use the cache. And under the hood, I could just do a silent request to the backend and kind of update the view when that data comes in. So the user gets like a more seamless user experience and they can start working right on some stale data. But that's kind of the purpose, right? It's just potentially a better user experience, stuff loads faster, reduce the load on the back end. But at the same time, it's a trade-off, right? Because now your users are dealing with stale data, and some systems have to be live, right? You can't show a table with a bunch of old data, and then after 3 seconds, it just like changes on your users. So it really depends on the use case of when you should be caching stuff. But that's kind of like an overview of the different things that you can cache. I'm sure there's a bunch of stuff I didn't even talk about, but what is the difference between local storage and session storage? So local storage is a storage location you can use that's persisted when your browser closes. Session storage, I believe, is only for your tab, and more specifically, when your tab were to close, it clears out your session storage. That's the main difference. So if you're like, why would you want to use local storage? Well, let's say they have some type of dark mode or light mode configuration. That makes sense to store in the local storage because you want it to basically persist when they come back to your application. Session storage would be stuff that's like ephemeral that you want to kind of clear out when they close the tab. Can't think of a good example, but I'm sure you can Google it. And then he said Redis was also brought up. So Redis is it's kind of like a database, but also like a caching solution. They also have like messaging built into it. It has like a bunch of features. Redis is pretty interesting, but a lot of software uses Redis kind of on the API side of things to cache things that are brought back from the database, right? So typically when your front end makes a request to an API, the API has to hit a database to get some data. Now, if depending on how often those queries are hit and how live or stale that data could be, you could potentially take all that data that comes back from the query and just put it in a Redis store so that now your API can hit Redis first. And since Redis is in memory, it's really fast to like kind of return those results back. So for example, if I had an API endpoint for like getting the user information for Bob, I could first check Redis and say, hey, Redis, do you have information for Bob? If not, I'm going to request data from my database, which is a little bit slower. And then I'm going to take that data that came back from a database, I'm going to store it in Redis so that if anyone in the future needs to request data from Bob, they can just get it directly from Redis. It's a lot faster. But again, you're storing potentially stale data into Redis, and you have to have some type of like time to live so you can clear the cache out and, consider the cache dirty so you can kind of like update it. So for an example, if a user were to like change his name from Bob to like Bobby, people are going to see Bob still for a certain amount of time. So that's the things you have to kind of think about when you're dealing with caching. But I think that's kind of good enough. What are cookies and what do we use them for? So cookies are ways to basically persist information on the front end. So like on the browser, you can store information about the user, maybe their session ID or something. And that's actually stored directly in cookies. So if you go to application and you go to cookies here, every page you're on has its own like list of cookies you can store, right? And a lot of times we do like authentication inside the cookies. Like we'll store information related to authentication, and we use the cookie data to verify that the person is logged in. Now, there's a bunch of other settings you can kind of set on cookies to make them secure. There's a lot of issues with cookies. If you don't have them set up properly, you can like leave yourself vulnerable to like cross-site request forgery attacks and stuff like that. But basically, all you need to do So for example, like if you use like an HTTP and secure cookie, basically what happens is every time the browser makes a request to your API, it's automatically going to forward the cookie on the request. Your backend can basically just keep checking the cookies that were set on the headers of the request, and they can just look up the session ID or something and use that to look up the user session from your database or from your Redis store to get information about if the user was authenticated and like what roles should they have access to in the application. That's usually what cookies are kind of used for. It's just kind of tracking the user's session. That was like a really high level overview of cookies. I don't know if I explained it well, but that's what I would kind of say. What is HTTP and what is REST? So HTTP is a protocol that we use to kind of define how the front end should talk to an API, or how like a web browser should talk to a web server. Okay, so every time you kind of like make requests, this is just doing an HTTP request using a particular protocol. And if you kind of dive into the protocol, I know nothing about it, I'll be honest. But there's like different headers in the request packets. There's like IP addresses for the request packets and all these other things. But some, really smart people kind of set out some standards of how like this information should be structured in the request, and like where certain things should be, and what you should be able to attach to the protocol, and what you should be able to attach to the methods. And that's kind of what HTTP is. Now REST, on the other hand, is basically using a subset of HTTP features, and trying to build out some type of conventions for how you can set up an API. So one of the things that HTTP provides us is you can send request methods. All right, every time you do a request to a backend, you can say, okay, this is going to be a GET request, or this is going to be a POST request, or this will be a put or a patch or delete. So REST is basically taking some of the conventions that the HTTP protocol provides us and trying to build a well-known pattern that a lot of APIs kind of follow, and everyone has like a very common convention to use to get data, delete data, update data, fetch data. And then I would probably look up like the CRUD REST endpoints. That's probably important to understand. Like typically you have like, let's say you had users. This would be like a GET request at users. Typically, if you have like some resources that have ID, you could do a GET request by the particular ID. You could create new users doing a POST request. You can update users by doing a put request. There's also a patch request that we typically do, like this. So these are basically the endpoints that we're hitting, right? You can do those HTTP methods, those request methods, to different endpoints. And this is just like a common convention that we use for RESTful services. Good to know. Make sure you definitely understand this. What HTTP verbs are there and when are they used? So again, I kind of talked about that. GET is for typically when you need to get back data. POST is when you need to create something new. Put is when you want to basically completely overwrite an existing record. And patch is when you want to just update individual fields on a record. So for example, if someone needs to change their name from Bob to Bobby, you could probably just do a patch and send in like a little piece of information, say change name from Bob to Bobby. Okay, so that's kind of like the verbs and how you kind of use them in a RESTful API. So that kind of covers all the questions I want to talk about. I mean, there were some more like React specific questions. I know nothing about MobX, to be honest, so I would probably skip this. I think he worked on a project before the interview that was asked to use MobX, so that's why they asked him about it, but I know nothing about it, so I'm not going to even talk about that. I could try to talk about these React specific questions. Explain the lifecycle of a React component. When are they mounted, re-rendered, and unmounted? So I have a really fuzzy understanding of like how some of the lifecycle methods work. I know that in React, when a component shouldn't be displayed, so for example, if I said false and I would say like my component here, this would basically, assuming that the component was already mounted and this is like a variable, but like let's say I said like is visible equals true. This is pseudocode, so don't get mad that I'm not using like real state. Some people don't have imagination, so let's just go ahead and do this. I'm gonna go ahead and do this so you guys can actually like follow along. Let's pretend we had some code here, some JSX code. In React, this thing is going to display, and if it's the first time this thing displays, it's going to be mounted, right? It's going to basically create the component, React does some stuff under the hood, and it's going to call a mount function, or if you have an effect, you can have it call the effect for the first time and do some stuff, some setup logic, right? When it's re-rendered, basically anytime you change state inside of my component, or if you change the properties that you're passing into the component, it's going to re-render my component. Now we're in like a parent component here, so I could say like function parent. And again, this is pseudocode, so and there might be like a bug, but I probably should return here. Anytime the state of the parent changes, so for example, if something were to change this state variable to false, it's going to basically rerun and re-render all of this code. All of this code and all of the children of this code and all the children of that code are going to re-render. So basically it depends on where the state changes, like in what component state changes, and also like what properties potentially were changed. And that's kind of when stuff gets re-rendered, I believe. I might even be right about the property stuff. Now for unmounted, so unmounted is basically if something were to come along and change this from true to false, React is going to think that, okay, I don't need to show my component on the page anymore, so I'm going to go ahead and just run the unmount logic and just do whatever cleanup I need to do. Typically, if you have like WebSockets that were set up in this component, when it mounts, you then want to clean it up and unmount those WebSockets and just clean up those resources. Everything about use effect. Again, for kind of achieving mounting and unmounting, you want to use the use effect function. Use effect is a function, I should say a hook in React you can use to basically run some behavior when something changes. And it turns out there's like this is kind of hacky in my opinion, but if you want something to only run once when the component mounts, you can do something like this and pass it an empty dependency array here. And anything inside of here, this is going to basically run once, unless you're using React strict mode in React 18, which makes it run like multiple times, which is super confusing and awful. But that's the idea. This is basically your mount logic. And then inside of this effect, you can return some type of code for handling the unmount logic. Okay. But use effect is also useful for when you want to like do stuff when variables change. So for example, let's say you want to run some code when the invisible Boolean changes from true to false or false to true. You can pass that in your dependency array and run some code to basically do some additional effects when variables of state change. I would try to avoid use effect when you can, because if you can just have stuff happen when you interact with the UI, it's much cleaner and easier to manage your code base. Yeah, I think that's good enough. I don't know. There's probably stuff I missed. How do class components differ from functional components? I've never written a class component in React. I'll be honest with you. I started basically with functional components, so I probably couldn't even answer this question. They're asking like not syntactically in relation to state management. I think what they're getting at here is that functional components allow for more composition, right? So you can easily have multiple mount functions fire, and you can abstract these out, right? So you can make custom hooks. And you can have like these custom hooks do their own mounting and unmounting behavior, which I don't think was possible with class components. I think you just had like a single mount function and a single unmount function. And setting up a bunch of different like custom logic for when stuff mounts and unmounts was like kind of a pain. But again, I never coded at all with like class components, so I don't know. But I think that's like the general idea, is that functional components with custom hooks made things a lot more like composable. That answers like all the questions. I hope this was kind of a good overview of those questions. And I think it's good to understand some of those questions, or mainly most of those questions. I don't think there's any questions that were like too out of the ordinary for asking a junior. Some of them were kind of like, okay, this is asking a little bit too much, but I am curious if anyone else has had interviews and has questions, like, and was asked questions in the interview, feel free to send me your list and I can try to make a video and kind of talk about them, and maybe I can try to answer the questions. I think these are pretty good questions to understand how to answer. I think answering them just helps people know that you understand React at a decent level and you understand JavaScript at a decent level. Some of the stuff I wouldn't ask about, like the React, the JavaScript prototype stuff, I probably won't even ask about, honestly. And there's some other stuff that I probably wouldn't ask about, such as like the scoping with block scope versus functional scope. I don't know. They seem like silly questions. But if you guys got some value from watching me explain these, be sure to like, comment, subscribe, and press the bell icon. And like always, I have a Discord channel if you want to talk to me directly or just ask me questions, or if you have been in an interview and you want to kind of forward some questions to me and have me talk about them in a video, feel free to do that. I can try to do that if I have time. Anyway, have a good day and happy coding.